Question 6 states, write a balanced chemical equation for the combustion of propane. So I will teach you for the excess oxygen. Okay, propane is C3H 6 to 8 C3H8 C3H8 plus combustion with oxygen, you get carbon dioxide and water lah. Okay, so this is gas, this is gas, this is gas, this is liquid. Okay, so to balance the equation, we check here. This is 3 carbon and this is 4, that become 8, right? So this will be 6 and 4, 10, 5. So this is the combustion in excess oxygen. In excess oxygen. Now let's say we look at the limited oxygen. So C3H8 gas, oxygen gas also, but limited will give you carbon monoxide gas and also water liquid. So this is limited, limited oxygen. So we balance the equation. Similarly, here we have 3 and here we have 4. Okay, same, So that is 3 oxygen and 4 oxygen, 7. So 7/2. Dapat ke guys? So you can see the difference, For excess oxygen, we get carbon dioxide. For limited oxygen, we get carbon monoxide. Tak sama, Boleh ke? Boleh, This is balancing equation lah sebenarnya. Okay, dekat thermochem pun kita dah belajar, Masa thermochem pun kita dah tengok. Alright, next is maybe we can look at okay, question 7 kot, 7. Draw the structural formulae of mono-substituted major and minor products formed when alkanes are subjected, alkanes below, subjected to bromination reaction under sunlight. So this is halogenation of alkane. So number 1, we have CH3, Br2 in CH2, Cl2, sunlight. So we only can get one product. Mono substitution kita dapat ni je lah. Of course with the HBr, right? Because we have only one class of carbon, that is primary and primary. So you get one product only lah. If you look at the second one, this one we may get 2 product. Okay, the same reaction, bromination under sunlight. The difference here is we have primary, we have secondary, we have primary. So we will get 2 product. The first one is CH3, CH2, CH2Br. And of course the next one CH3, CH, CH3Br. And we have HBr. But then if you don't give the HBr, that's okay, no problem. Because our concern is about the major and minor. So this is, as we can see, this one comes from primary. That means this is our minor product. And obviously this is our major product because it comes from the secondary. Boleh ke? Setakat ni boleh ikut ke? Boleh, Okay, bagus. So CH3 yang ketiga. Boleh, very good. Okay, CH3, sama macam tadi juga. Kita tengok classification. Primary. Yang ini tertiary. Okay, tertiary, So by now you should know the answer already. So we have Br2 in CH2, Cl2, UV. So yang minus saya lukis satu je lah, CH3, CH2, CH, CH2Br. CH3. Okay, and plus we will get CH3, CH3. Dah tak ada CH dah sebab akan diganti. So kita terus CH3 atas CH3, sini H itu diganti dengan Br. Okay, so we take note here, this is again our minor because the substitution occurs at primary, and we have the second one as major because it occurs at tertiary. Okay guys, for this structure boleh? Okay, good. Okay, number 4 is recycling tapi proses dia sama saja. So we find this is secondary, this is secondary, this is secondary, this is secondary. So tak kisahlah mana-mana maksudnya kita hanya dapat satu produk je lah, Br2 in CH2Cl2 UV. So we only get one product, that is, kejap, lukisan tak berapa kemas. Allah, like that. So Br plus HBr. Okay, mono substitution lah, semua sama lah. Alright, then we go to, this is A, just now bahagian A. Okay, now we go to B. B, by referring to structure 7A3, write an equation to show the formation of product. So for this answer, I already done in A part 3. You boleh refer sana lah. Saya dah buat kat sana. Okay, now we want to do mechanism. Okay, so very quickly, I hope you practice all the mechanism for halogenation of alkane. So step 1, chain initiation step. Okay, chain initiation step, Br, UV, one goes here, one comes here, so we get Br dot. Okay, step 2, chain propagation step. Okay, chain propagation step, the first one we have the structure number 3. So CH, CH3, CH3, CH3 plus Br dot. Okay, so one goes to carbon, homolytic cleavage, one goes to carbon, one collide with the bromine. So we get H3C, CH3, CH3, we get a radical plus HBr. Okay, in the B step, that radical CH3, CH3, this radical will collide with the bromine molecule. Okay, so what will happen? This will collide with this bromine, one goes to this bromine. Half aided arrow, do not forget, arrow dia berbeza, dia half aided arrow. So H3C, CH3, CH3, and then we get Br, and this one become a radical. So far, can follow guys? Step 1 and step 2. Boleh ke?
Boleh, sir.
Boleh Kita pergi ke step yang ketiga. Step 3 is chain termination. Step. Okay, chain termination step, kita terminate lah semua radical bermula dengan bromine. Okay, so this one collide with this, we get Br, Second, kita ada radical daripada alkyl. Okay, this radical collide with bromine radical. Okay, so we get the product, obviously. And finally, we have the alkyl radical collide between themselves. Okay, mereka langgar sesama sendirilah. Okay, so this one collide dengan, this one collide with this one. Okay, so we end up getting H3C, C, CH3, CH3 dash C, CH3, CH3, CH3. Okay guys, can get the mechanism? Boleh ke termination dia? Ke ada apa-apa soalan? Okay, good. So moving into question B3. So they want the observation, give the observation of the reaction. This is supposed to be our experiment 4. Unfortunately, we can't do physically, but I hope you have watched the video. So if you watch the video, the observation will be reddish brown of bromine will be decolorized. Betul ke? Kalau letak di bawah cahaya matahari, sunlight, alkane, you find the bromine, which is brown color, the reddish brown will be decolorized or turn into colorless. Okay? Boleh? Boleh. Kemudian dia tanya, what would happen if the mixture kept in the dark at room temperature? Kalau tak ada cahaya matahari, let's say we don't have the UV, no UV, atau you kata keep in dark, what do you think will happen to the reddish brown? Apa jadi pada reddish brown? No changes. So kita kata remains same ataupun unchanged lah. Reddish brown remains same or unchanged.